Okay, so you will remember that our friend Milliken, by the way, your video project is due Friday, and I only have, I don't know if I have anyone from this class. There's a spot on Schoology to submit. Okay, so you'll have some time this week, but I do need those in by Friday, you guys, because I don't have a lot of time to mark. Okay? All right. So you will remember our friend Milliken. Our friend Milliken had charges suspended between the electric plates, and this meant what? That the forces were balanced, and you might also say that the net force was 0. So today's topic is, what happens if they are not balanced? Well, if they're not balanced, there will be a net force, which will cause a acceleration. And so you get unbalanced F net, and you get at this acceleration. And using this net force and acceleration, we can solve problems for motion electric field. Now, I know exactly what this is right here. What I'm saying right here is, if you had an applied force and a friction force, right, like that, like we did in unit number 3, and if you just sort of think about that, but instead of being horizontal, if you think of it being, that's all we're talking about. So we're taking something that you've seen already, unit number 3, and we're just kind of flipping it 90 degrees. That's all we're doing. Flipping it on the side. Put it standard on its ear, exactly. That's all we are doing. Okay, now a couple other quick things, just to sort of, I'm going to skip over that. I need you to know that inside the electric field, inside the plate, there's a calculator there, Kaylee, or what are you doing there? Oh, okay. Yeah, stay with me here, okay? There'll be time. Because then I don't have to re-explain this just to you. That's no good. Okay, so inside the plate, inside the electric field, is where it's stronger, because remember I showed you you've got the red from the red plate, plus you've got the blue, right? So it's like double the strength. Now there is a little bit of curvature at the sides. We're just going to sort of ignore that. Okay? So let's jump right to those sample questions. Okay? And I think you should have those right in front of you. So this is sort of like the Big Daddy. This is about as big as it gets. Pretty much. Okay? So stay with me here. Jot these down. Try and keep up if you can. And I'm just going to go get my... So here we go. Now, the biggest problem, one of the biggest problems, Adam, eyes up here, Adam. One of the biggest problems is students have a hard time figuring out what the different things represent. Okay? So you got to start reading here. A 1.0 times 10 to the minus 4 kilogram charge. It doesn't say what it is, does it? Your only clue is the unit, which is kilograms. So that means that is our mass. 1.0 times 10 to the minus 4. Okay, so you have to watch for things like that. You got to be able to read. That's the mass. 1.0 times 10 to the minus 4. Charge of 3.2 times 10 to the minus 19. That is our Q. The plates are 1.5 centimeters apart, so what would you call that? Distance. The electric field strength is 1.0 times 10 to the 15 newtons per coulomb. So that is our E. Exactly. Determine the net force. F net. With me so far? Okay, so let's draw a little picture. So, sort of a Millikan apparatus. We've got weight force down and we've got electric force up. Now, I don't know which one is bigger, do I? Yeah. Right? But I know one's up and one's down. And we know they're not balanced. Right? What do you feel should be step number 1? Finding FW, I heard someone say. I think that's a good place to start. The weight force FW is equal to mass times gravity. The mass, again, 1.0 times 10 to the minus 4. Gravity is minus 9.8. And you could probably do that in your head. Because, well, it's just times 1. 9.8 times 10 to the minus 4. What's up with that one, Will? All right, well, moving on. So we have our weight force. Now we need to find the other one, which is the FE, right? Now I know, don't write this down. We've been writing this like this before now, right? Okay. You may have started to realizing that you can write it like this. All that is the same formula, just reworked. Why not? Okay.
Oh, what happened to it?
However you want to write it. It looks like this, right? So the electric field strength is 1.0 times 10 to the 15. We are solving for the FE, and our charge is 3.2 times 10 to the minus 9. Not balanced, because we're asked for the net force. That was, remember Kaylee at the start? So we are going to multiply, right? And you're going to get 3.2 times 10 to the minus 4 newtons. Okay, now, these two forces, I'm going to wait. These two forces should be of comparative same size. They should have the same order of magnitude, is what the scientists would say, right? They're in the same ballpark. It's like having $1 and $6 as compared to having $1 and $1 billion. One loony and $1 billion is not the same ballpark. Okay? $1 and $10 is the same kind of ballpark, right? Order of magnitude. So in other words, this exponent here and this exponent here should be the same, or if they are different, no more than 1. Maybe 2, but unlikely. So like if one is minus 4, the other one should be like minus 5, minus 4, minus 3. If one is minus 4 and the other one is plus 17, that's like $1 billion and $1. Completely different. Alrighty, so what's the next step? Determine the net force. So what are my forces? My FE and my FW, and that is it, right? So we're going to write that the net force is the sum of all the forces, which is FE plus FW, right? You're just adding them together. 3.2 times 10 to the minus 19 plus negative 9.8 times 10 to the minus 4. And that should not be 19, that should be 4, shouldn't it? No, it doesn't matter. I was actually, I did it again. Does it matter which order you put them in? Is 3 minus 2 the same thing as minus 2 plus 3? Same thing, right? Yeah. So minus 6.6 times 10 to the minus 4, right? Newtons. That is your net force. Now, Travis, is any of this new?
No.
We've done that before. And we've found net forces before. So all this is taking little bits and pieces of things that you already know and just putting it together. Pardon me? Did that come into play at all? No, I threw that in there just as a reminder that sometimes the writer of the question likes to be a jerk and does stuff like that. Well, it might if you need to know like how long it takes to go from one side to the other, right? Something like that. But in this case, it's not going to make any difference. Sure. Okay, here's what I'd like you to try. The next one, let's just have a look at it here. I'll get you going on it. I'll come, Kelly. We got a 4.5 times 10 to the minus 6 kilogram charge. So that again is the mass. You're going to. This is the charge. You know the E value, but now they're asking for the net acceleration. So is that not just these 3 steps and then you're going to go? F net equals ma, right? Give that one a whirl. Yes. Okay. Okay, so there's the first 3 steps.
Motivation, Connor.
Yeah.
That's what we were working down and got into the teacher.
Like next period, you mean?
Yeah, next year I have permission to.
Okay.
I'm just saying. That's why I went.
But that's the next period.
I know, next. I was just saying that.
Okay. I'm not sure why I need to know if it's next period. Minus 3.35 for the acceleration? No, Jaden. Jaden, no. Yeah, no. Okay, that's the acceleration. Yeah, that's fine. That's close enough. Close enough, you guys. Yeah? This? No. You can probably leave this out as long as you just say that VF equals that. You guys can do this, thousands before you have and thousands after you will as well. It's within your ability. I'm going to scroll down. I'm going to ask you to try the third one now. No, you're going to try it. Okay? The third one is, hang on you guys, I'm going to get to everyone. Hang on, I understand. Now is not the time to ask a question. Okay? I'm going to be done in about 30 seconds. Then would be good time. Okay, so the third one is you need to find the charge and the droplet. This is basically exactly what Millikan did. He was trying to find the charge. Okay? So work with a partner. Try number 3. I'll give you about 10 minutes, and then I'll give you the answer.
Do it But Connor,
Can you pass through the 60?
Yeah, of course you can.
Good on
Yeah. Okay, Jaden, just relax. Jaden, smart enough. What'd you get? Did you get 3? 3 is the correct answer. Now, if that was a charge of -3, would that mean, and you gotta think about your chemistry here, if that was a charge of -3, would that mean that it has extra electrons or missing 3 electrons? If it was a negative charge. If it's negative charge, that means it has more electrons than protons, so it would have 3 excess electrons. It would be like, what are that called, right? Okay. So you've now got, on the back side of that paper, there's, I think, 7 questions that you can practice with. Okay, it is practice. There are answers, there are solutions, etc. there. Okay? If you haven't completed pretest number 1, you need to do so. If you don't have pretest number 1, you need to come and get it. Pretest number 2 is coming. Are we going Wednesday or Thursday? This week.
You'll have an exam next Wednesday, right? What do you want? What do you do? You meet your own person.